Okay, in this video, we are going to learn about non-deterministic finite automata. Okay, so far what we have seen is a DFA or a deterministic finite automata. So most of our examples, when we started designing FAs in general, FAs means finite automatas. So in FAs, there are two classifications. One is DFA. We have had this discussion in the initial videos. So we also have another type called NFAs. That's called non-deterministic finite automata. So whatever we have seen as of now is a DFA. So we will understand clearly the difference between a DFA and an NFA. Okay, and we will try to design NFAs for those problems for which we have already designed DFAs. Okay. Okay, before actually going to non-deterministic finite automata, let's understand some of the features of DFA. Okay, so you can see here the DFA for binary strings ending in 0, 1. So this is a problem which we have worked out earlier. So from this diagram, we can understand that from every state, all transitions should be defined, or the transitions on all the alphabets. For example, the alphabet set here is 0, 1. So from Q0, you should define the transition for 0 as well as the transition for 1. So it is applicable for every state. For Q1 also, you should define the transition on 0 and transition on 1. Similarly, from Q2 also, you should define the transition on 0 and 1. So for every state, you have to define the transitions on the entire alphabet set. In this case, our alphabet set is 0, 1. So the transitions on 0 and 1 has to be defined for all the states. So one of the important properties of DFA is that transitions for all the states should be defined for all symbols. Okay, for all symbols, transitions from all the states must be defined. Another property is that you cannot have multiple transitions from a state for the same symbol. For example, if you are looking at this particular DFA, you can see that from Q0, if you are getting a 0, you are moving to Q1. Okay, and we cannot define a transition like from Q0. If you get a 0, you can go to Q1 or Q2. This is not allowed in a DFA. So that means I cannot have a transition representing from Q0 to Q2 saying 0 again. Okay, so because 0 transition is already defined here. Okay, and so I cannot draw a transition like this. This is invalid for a DFA. Okay, so that's another property. So let me write it down. There cannot be multiple transitions on the same symbol from a given state. So this is very important for a DFA. That is, multiple transitions are not allowed for a given state on a particular symbol. Okay, so from Q0, if you see a 0, it should be a unique state. Okay, we should not say upon seeing a 0 from Q0, I have the choice of going to Q1 or Q2, and this is not at all allowed in a DFA. So whereas things are very different for an NFA. So let's look at how an NFA, let's look at the non-deterministic feature of a NFA. So the idea of non-determinism is like this. So it gives a machine multiple options for its moves. So your NFA is such a machine which supports or which allows non-determinism. That means NFA can have multiple options for its moves from a given state. So we can understand non-deterministic finite automation as like this. So in a non-deterministic finite automation, for each state there can be 0, 1, or 2 or more transitions. Okay, so it's completely different from DFA. So a DFA can have only one transition. So can have only one transition from a given state to another state. But whereas in a non-deterministic finite automata, we can have 0. You need not have any transitions at all. That's also valid. You can have one transition. You can have 2 transitions or more, or even more transitions, which corresponds to a particular symbol. So for a given for a DFA, only one transition is allowed. So in fact, we can say that all DFAs can say that all DFAs are NFAs. All DFAs are NFAs. But the reverse is not true. All the NFAs cannot be DFAs, right? Because NFAs allows zero, zero and two or more transitions from a given state on a particular symbol. Okay, so all DFAs are definitely NFAs, but the reverse is not true. We cannot say that all the NFAs are going to be DFAs. Okay. So we look at this example itself. This is an example where we have designed the DFA for binary strings ending in 0, 1. So we will see how the corresponding NFA can be made. So the design of NFA is very straightforward, as we don't have to define for every symbol. Okay, so we have the freedom of choosing only the required symbols and proceed further, right? So the design of NFA is generally easier compared to DFA. So let's look at designing the NFA for binary strings ending in 0, 1. So what I'm going to do now is to design an NFA for binary strings ending in 0, 1. The same question for which I'm going to design the NFA. Okay. So as you know, in NFA, we need not define all the transitions on all the alphabets. Okay. We can also have multiple transitions on the same symbol. Okay. So what is our requirement is that the binary strings should end in 0, 1. So if I'm getting started at Q0, I can say that as long as I see a 0 or a 1, okay, 0, 1, I can stay at Q0. Okay, now I can have a transition on 0 here again. Okay, so upon seeing a 0, then I can also go to Q1, right? And then I can say, if I see a 1 after that, then I will be at Q2. And Q2 is going to be my final state, right? So here are few important things to be noted. And this is the NFA. That's it. There is nothing fancier than this. Okay. So you can see that from Q0, I'm saying that if I'm getting a 0 or 1, I can stay at Q0 itself, or I have the option of going to Q1. Okay, there are two options. From Q0, let me make it very clear. Okay, from Q0, if you see a symbol of 0, you have got two options. You can either stay at Q0 or you can go to Q1. So these two branches are possible. You can either take this path or you can take this path. So these are the two paths available, right? And now from Q1, look at Q1. From Q1, the 0 transition is not at all defined. So from Q1, you don't have a 0 transition. So 0 transition is not at all defined at Q1. Similarly at Q2, none of the transitions are defined. Not 0. 0 transition is not defined. Also, the transition on 1 is also not defined. So you don't know what to do upon getting a 0 or a 1. Okay, that essentially means that, so from Q2, if you're getting a 0 or a 1, you actually go to a dead state. Okay, so that's the meaning of it. Okay, so from Q1, similarly from Q1, if you're getting a 1, you have the choice of going. You can actually go to Q2, right? That's how it is defined. But from Q1, if you're getting a symbol as a 0, you actually don't know where to go. So if you're getting a simple 0 from Q1, then you are going to a dead state. So from this knowledge, we can understand that an NFA has many different ways of processing a given string. So suppose in this example, if the given binary string is say 00001, then it means that the NFA can process it in different way. Okay, so one of the way is that I consider, whenever I see S0, I will be staying at Q0 itself. Okay, so suppose if I'm doing that for all these first four zeros. Okay, first four zeros, what I'm going to do is I'm going to stay at the same place, right? And then when I see this zero, suppose the NFI decides to continue further, right? And then it sees a 1, right? It sees a 1, and then it will be reaching to the final state Q2. Okay, so that way, this particular, if you take that kind of a path, then this binary string is said to be getting accepted. So it is getting accepted in that particular fashion, right? If the NFA decides to stay at Q0 for all the zeros, all the 5 zeros that it sees, okay, then after all the 5 zeros, still you will be at Q0 itself. Okay, so upon seeing a 1, then you're suddenly seeing a 1. Again, you are going to be at Q0, right? So your ending state is going to be Q0. Okay, and so in that case, this particular string is not getting accepted, right? But generally for an NFA, we say that a string gets accepted. Okay, so for the case of an NFA, we say that a string gets accepted if it gets accepted in any one of the paths, in any one possibility, any one of the paths. In any one path, if this particular string has the possibility of getting accepted, then we say that this string is getting accepted. So the idea of acceptance is completely different in an NFA. So you should not have you can try all the possibilities, you can try all the paths, okay, and then if you find any one path through which you can reach to the final state, then we say that that particular string is accepted by that NFA. Okay, so if you see, suppose in this case itself, so suppose if we plan to stay at 0, but by seeing all the 5 zeros, upon seeing all the 5 zeros, we plan to stay at Q0, and then we see a 1, then we will be finally at Q0, right? So we have not reached the final state at all. But again, this string is said to be accepted just because of the reason that there is another way. Let me take my pointer. So what it means is that if I decide to stay at Q0 for the first 4 times, that means when I see this 0, I'll be at Q0. Again, the next 0 also I'll be at Q0. Again, for the next 0, I'll be at Q0. Again, for the next 0, I'll be at Q0. But when I see the 5th 0, I'm planning to move forward. Okay, so I am at Q1. Then I see a 1, right? So then I am at final state, right? So the condition that you should have any one path. Okay, so so if I take that decision, then I have a path for reaching Q2. Okay, and hence this particular string is said to be accepted. Now suppose that our string is 0 0 0 0 0 1 and 0. Okay, so if this is the string, so we have designed the NFA for strings ending in 0 1, right? So this is not ending in 0 1. This particular string is not ending in 0 1. So let's see what are the possibilities of processing of this string by our NFA, and how it is not at all getting accepted. So you cannot find even a single path by which you can come to the final state. So in this string, what if I plan to stay at Q0 itself for the first 4 zeros, and then if I'm seeing this 0, upon the 5th 0, I'm going to move to Q1, right? And then I am seeing a 1, right? Then I am at final state, right? I have reached the final state. But the important thing to remember is that the string is not at all complete, not yet complete, right? You have one more 0 pending there, right? So from Q2, the transition on 0 is not at all defined, right? So it means that since the transition is not defined, it is going to a dead state. Okay. So even though we feel that we are at the final state at this point, till here when we reach, we are at the final state. But you have one more remaining symbol, and whose transition is not at all defined at Q2. And then we understand that we are going to a dead state. We don't know what to do, right? So this string cannot be accepted in that way. Similarly, you can try many other different paths also. I can say one more path, right? So if I'm doing like this, suppose for the first two zeros, I decide to be at Q0 itself, right? And for the next zero, I'm going to go to Q1, right? And so for the first two zeros, I stayed at Q0. Then for the second zero, I'm at Q1. And from Q1, I am at Q1 currently. And from Q1, I don't know what to do upon seeing a zero. So it means that I am going to a dead state. So that way also you cannot accept your string, right? So you cannot process it further. So that means your string gets rejected. Right. So in this for this particular string, you cannot find at least one path. You cannot find even a single path on which this particular string, you can try all the possibilities, try all possible paths, and then also you cannot reach to the final state. In the sense, even if you reach to the final state, there will be some symbols remaining, and that means you are in a dead state, right? So this is a major confusion people are having, right? So I can say that after seeing the first four zeros, let me make it very clear. After seeing the first four, after seeing for seeing the first four zeros, I decide to be at Q0 itself, right? And then upon seeing the next zero, I'm moving to Q1, and then I have a 1, so I will be at Q2. Okay, so I will be at Q2, but remember, you have one more symbol. You have one more symbol, right? So when you see 0 after this 1, right? After this 1, when you see a 0, you actually don't know where to go. So you are actually at a dead state. You are not going to be at Q2 itself, Q2. Even though you came to Q2, but your symbols are not complete. Your string has one more symbol left, and that is going to be 0. And upon 0, you don't know where to go. And so we cannot say that the string gets accepted, because you don't know what to do with this 0. So you are at a dead state if you don't know where to go. And in the very similar way, you can try all the different paths, and for this particular, to process this particular string, and you can see that none of the possibilities will lead you, or I can say all the possibilities will lead you to either to a non-final state or to a dead state, right? So you will either reach a dead state. So when are you going to reach a dead state? That means if suppose you are at a state, and then you are encountering a symbol, and the transition of that symbol is not defined, then we say that you are in a dead state. For example, if you are at Q1, and if you're seeing a 0, that particular transition is not defined, so then you are said to be at a dead state. Similarly, if you are at Q2, and if you're seeing either a 0 or a 1, okay, none of these transitions are defined here. So if you see any symbol after you are being at Q2, okay, so then you are going to be at that state. So these three points are very important to be kept in your mind with regard to NFAs, right? So from a given state, transitions to multiple states can be defined on the same symbol, right? That's important thing. For example, in the DFA that we have seen, right? So sorry, in the NFA that we have defined here. So this is an NFA for accepting binary strings ending in 0, 1, right? So in this NFA, you can see that Q0 upon 0, there are two different possibilities. Q0 upon 0 can go to Q0 itself or Q1, right? So the transition function on Q0 on 0 can be defined to Q0 itself or to Q1. So that's why we write delta. That is a transition function on Q0 to 0 can go to Q0 or Q1. So that is a set. Okay, so that's going to be a set. So this means that when you see the simple 0 from Q0, you can be at Q0 or at Q1. So there are two possibilities. So that's why we say that there are multiple transitions possible. Transitions to multiple states can be defined, right? And the second important thing is that from a given state, the transitions can be left undefined also, right? For example, in this NFA itself, from in Q1, we have not actually defined the transition for 0. So the transition for 0 is not at all defined here, right? But the transition for 1 is defined, but the transition for 0 is left undefined. Similarly, at Q2, you can see that none of the transitions are defined. There is the 0 transition. There is no transition on 0. There is no transition defined on 1 also. So it's quite valid to have transitions left undefined in an NFA, right? So these two things are not at all possible for a DFA. So we should have we must have defined transitions, all the transitions for all the alphabets, but we also should not define transitions to multiple states on the same symbol. So these two things should not be there for a DFA, but these things can be possible. These things can be possible for an NFA, right? It is not a must, but it's possible. Okay, so it's quite possible to have multiple states defined on the same symbol. That's possible, right? Similarly, from a given state, transitions can be left undefined. Okay, so don't think that it is a condition, it is a mandatory condition. No, it is not a mandatory condition, but it is possible to have these two things, right? Similarly, the third important thing is, so a string is said to be accepted. So if there is at least one path which leads you to the final state. So remember, when I say which leads you to the final state, and from the final state, you should not go to a dead state, right? For example, from Q2, suppose you are reaching to Q2, and then from there, if you are seeing a 0 or a 1, then you will be in the dead state. So we cannot say that we are at Q2 then, right? So a string is accepted if there is at least one final path that will keep you in the final state. So now in the next video, I'm going to define the mathematical definition of an NFA. So we will also find the difference between the mathematical definition of a DFA and an NFA. Okay, so I actually wanted to run through this example. So in this example, we have seen the example of a particular DFA, that is binary strings ending in 0, 1. And we have also drawn its corresponding NFA, and we were able to identify the features of NFA. And you must have a reasonably good understanding of how an NFA is different from a DFA. So in the next video, we will look at the mathematical definitions.